So our next problem is Leetcode 865, which is smallest subtree with all the deepest nodes. So given the root of a binary tree, the depth of each node is the shortest distance to the root. We need to return the smallest subtree such that it contains all the deepest nodes in the original tree. A node is called the deepest if it has the largest depth possible among any node in the entire tree. Node is called deepest if it has the largest depth among any node in the entire tree, and the subtree of a node is tree consisting of that node plus the set of all descendants of that node. So all the children of that node along with the node itself. So we need to return the smallest subtree such that it contains all deepest nodes in the original tree. All the deepest nodes in the original tree, right? So for example, for our first example, we have basically 3, 5, 1, then 6, 2, 0, 8. Then null means that 6 has no left and right child, and 7 and 4. So basically in this example, we return the node with value 2 and its subtree because the nodes colored in blue are the deepest nodes of the tree. That is, they are at the highest or the maximum distance from node 3. So this is basically, you can see they are at distance 3. So 1, 2 and 3. So these are the deepest nodes from the root, and therefore we return the nodes 5, 2, 7 and 4. So that's the answer. Notice that nodes 5, 3, 2 contain the deepest nodes, that is 5, 3 and 2 contain the deepest nodes in the tree, but node 2 is the smallest subtree among them, so we return that. Because we need to return the smallest subtree such that it contains all deepest nodes in the original tree. And you can see for this example as well, for 1, the deepest node would be 1 itself, so that's the answer, that's the base case. And for let us say 0, 1, 3, null and 2, for this are, this is null, and this is also null, this is also null. So for this, the deepest node in the tree would be 2, and the valid subtrees are subtrees of nodes 2, 1 and 0, right? So these are the subtrees of 2, 1 and 0, but the smallest subtree of node 2 would be the answer, that is the node 2. So how do we solve this? So let us go to the solution. I have posted the solution in the solutions tab. You can find this under my name. So intuition is that we are given a binary tree and asked to find the smallest subtree that contains all the deepest nodes. First we need to find all the deepest nodes, that is the nodes that are farthest away from the root, that is on the bottommost level. Then we find the lowest common ancestor, LCA, of all those deepest nodes, right? We are finding the lowest common ancestor because the LCA of these nodes will actually be the root of the smallest subtree that contains all of them. So it breaks the problem into two simple problems. The first one is to find all nodes at the deepest level using level order traversal, which is breadth first search, BFS. And secondly, we have to use LCA. So compute the LCA of those deepest nodes using a help function, LCA. So approach is level order traversal, perform BFS level by level to collect all nodes, and the last level will contain all deepest nodes. Then use a recursive function to compute the LCA of two nodes. Iterate over all the deepest nodes that we have, and successively compute the LCA of the current LCA and the next node. Then return the final LCA after processing all deepest nodes. So that would be the root of the smallest subtree. Complexity we have as n times d, O of n times d, where n is the number of nodes in the tree for BFS and for LCA calls, and d is the number of deepest nodes, that is the last level size. In the worst case, LCA would take O of n per pair. And the space complexity is O of n again for storing the level order traversal and recursion stack in worst case. Now let us go over to the code part. So basically this is our LCA function, and this is the subtree with all deepest nodes, right? So first let me discuss the LCA function. So it takes the root and the nodes P and Q for which we are finding the lowest common ancestor. So let me just draw a tree for example to show you how it's working, right? So let us say this is the graph that has been given to us, and let us say this is the node P and this is the node Q, right? So the lowest common ancestor of P and Q, LCA of P and Q, would be equal to this node, which is let us say it is marked as 0. So this is the lowest common ancestor because this is the point where these two nodes will meet. Okay, so if the current node is null, we return null. So if root is null, then we return null. If the current node is root is P or Q, then return that node. So if the current node itself is P or Q, that means that would be the LCA, so return that node. These are the base cases. Now we recurse for the left and right subtree. That is, for the left subtree, we calculate the LCA of roots left. So basically we are calculating, for initially the function is called on LCA root PQ, but now we have to go to the roots left, so we call LCA root left and store it into left subtree, and right again we call that for LCA root right. If both left and right are non-null, the current node is actually going to be the LCA. That is, if both are not null, then the current node is the least common ancestor. If only one of them is non-null, then return the non-null node, that would be the LCA. So the non-null would be the LCA. So this is our LCA function briefly, and now moving on to the main function, that is subtree with all the deepest nodes. So if our root is null, we return 0 obviously. Now we start performing our level order traversal. So we have result in which we store our results, right? And Q is basically used for the BFS to get the nodes at each depth, and we push the root, that is the node from which we are starting, into the Q. So a standard BFS algorithm we use while queue is not empty, n is equal to queue size, which is number of nodes at that level, and we maintain a vector of tree node star type, which will store the levels of each basically level of each node when we are traversing. It will store the levels for each of them. So let me show you. Basically, this is level 0, level 0, this is level 1, this is level 2, and so on. So basically, in the vector, it would store levels, and in this result vector, this would store all of these like in this format: 0, 1, 2, right? So in this vector format, 3, 4, 5, 6, and so on, right? So this is level 0, this is level 1, and this is level 2, right? Now for int I is equal to 0, so I less than n, I plus plus, we are going over all the nodes in that level. Node is equal to q dot front and popping out the node, right? So popping out that element, and node, if the node is not null, we push it into the level, and we check if node's left exists, we push that into the queue, and if node's right exists, we push that. So we are basically performing this to populate our level and finally our result. So res dot pushback level. So we've gotten our level order traversal res. So n is res dot size, and we are going over to the last level. So the last level is basically the area where we have the leaves. So for example, this was the tree given to us, right? Let us say this is the tree. So the last level contains the leaves. So we go a result of n minus 1, which is res dot back. You can also write this down that we can use as a function, that we are covering the deepest or the last level, because this level would have the deepest leaves, right? So if only the deepest node exists, it is the answer. So if only one node exists, that is if last level dot size is 1, then only one would exist, right? So we return last level ka 0th element, that is the only element that is going to exist. And in example 3 also you saw that it was only 2, because it was the only leaf present in the tree, right? So that we can do. Now we find LC of all the nodes in the last level. So LC node we have considered at last level 0, and for we basically get LC of all the deepest nodes, that is for I equal to 1, I less than last level dot size, that is for all these nodes, all the leaf nodes, we calculate the LCA, right? So the LCA would come somewhere out here. So LCA node, we once we recover, right? So for this would be the LCA. So once we get the LCA, that would be the answer, that would include it, that would be included in the answer, and we return LCA node, right? So that's it about the video.